Hello, mathematicians, puzzlers, and other curious people. If you're wondering about why we would need to be able to calculate percentage growth or percentage decrease more flexibly than just by calculating the percentage and then adding or subtracting it, one way is in dealing with tax-inclusive pricing. So in this situation, we're looking at the case of a ceramics artist who is going to be selling 4 types of products at some craft fairs, and she doesn't want to have to deal with coins, so she wants to have it be that all her prices, including tax, come out to a whole number of dollars. This deals with percentage increases over whatever that base price would be before the tax, and in order to find out what that price would previously be, we're going to need to use just a little bit of algebra. So I see we need to look at what the price including tax would be on just $17.50. So I'm grabbing a calculator, and with that calculator, I'm going to calculate $17.50 times, well, what's my amount including tax? So I see that there are 2 different tax rates, 7.5% and 8.25%. I'll deal with both eventually, but I'll start with the 7.5%. So adding 100%, that would be 107.5%. So 1.075. The price including tax needs to be not less than $18.81, so I will set that at $19. That's the tax-inclusive price, but she needs to know for her bookkeeping what the price before the tax would have been. So here's what I see. The price times that growth factor, 1.075, needs to equal 19. Then we just divide that out the usual way for algebra. So 19 divided by 1.075, $17.67. Now I see we have several of these to do. Spreadsheets are great at that. Here's what we really did. We took our base price, $17.50, and we calculated the price after tax. So we took that base price minimum and multiplied it by a growth factor including the tax, so 1.075. From there we said we need to round that up. Spreadsheets can do that for us. And then what we needed to do was back out the sales tax. So divide back off that growth factor. So divide by 1.075. Always a little troubleshooting to do. And then we get that $17.67. Now it turns out it's very easy to just continue this through. Copied the rest of the prices, and here I am autofilling the rest of the formulas down. So now I see that our prices after tax would be $26, $34, and $46 for the other products, and the prices before tax would be $24.19 and $31.63 and $42.79. You might also say, wait a minute, what about when the tax rate is something different? So what we want to do is adjust this formula so that we are using the needed growth rate. So before we were using strictly 1.075, but I'm going to set up a box here that we put our growth rate in. So before it was 1.075, and now every place I'm using that number, I'll refer to that cell instead, and it won't change any results. Now I know I'm going to drag it on down, so I'll need to put the $sign that's like an S for stay put, and I'm not ready yet, so I'm not taking any of its advice about what to do. But now I can change my growth rate to 1.0825 for the 8.25% tax rate, and this changes some of my results. So now I can drag this on down and I get my all new results again. So I see that the price including tax is actually the same, so that didn't change from one location to another. But the back-end price that this ceramics artist uses in her inventory system is going to be different for her bookkeeping. So the bowls will be $17.55. The mugs will be $24.02 on paper. And again, $26 after tax. The vases will be $31.41 in the back-end bookkeeping system. And the teapots will be $42.49. And we did all that just by using some growth factors and a little bit of algebra so that we would know what calculations to do. And then we fed it all into a spreadsheet because we're lazy like a mathematician and we wanted it to do the arithmetic for us. So that's just one little example of how growth factors can be used for calculations in the real world. Calculator!